This is the last video in the trigonometry unit, our last lesson in the trigonometry unit, and it deals with solving triangles that don't have right angles in them, and you need to use two different laws. One is called the law of sines, and the other the law of cosines. Let's start with the law of sines. So it's called the law of sines, and it's a cross multiplication where you compare the sine of an angle with its opposite side equaling the side of another angle and its opposite side. So I used sine A over A equals sine B over B. Notice the capital letters for the angles and the small letters for the sides, always opposite to one another. So on this triangle right now, I want you to notice that I've given you two different angles, and the relationship that you always want to look for when you're using the law of sines is you want to know an angle and you want to know its opposite side. So I'm going to start with that one, and I'm going to write it down as a fraction. I'm going to say the sine of the angle 70 degrees divided by its opposite side, 50. And then you want to look to see what you're trying to find. And you notice that you've got the angle here, and you're asked to find the missing side opposite to it. So I'm going to say the sine of 75 divided by its opposite side, lowercase j. So that creates a cross multiplication. And so what we're going to do is we're going to circle on the diagonal where we have the two numbers, 50 times the sine of 75. And then we will divide by the ratio, in this case outside the triangle, which is sine of 70. So type that in on your calculator. 50 times the sine of 75. And then divide that by the sine of 70. And you get an answer. Side j, lowercase j, is equal to about 51.4 centimeters. So notice the relationship that I started with, an angle and its opposite side. Those had to be both numbers that you knew. On our next diagram up here on the right, you'll see that we only have one angle, but we do have its opposite side here. So this is the relationship you're looking for. You want to know these two numbers right here. And in this case, it says, can you find angle P? As it stands right now, we couldn't find angle R because we don't know its opposite side, but we can find angle P, so that's what we're going to do. So I'm going to write it down like this, starting with the ratio that I know. The sine of the angle, 80 degrees, divided by its opposite side, 42, equals, now if we're trying to find angle P, it's something that we don't know, right? That's a question mark. So we say the sine of capital P divided by its side, 25. So we still have a cross multiplication, but this time we're trying to find the angle. So it has a two-step process. You want to circle the two numbers that you know and divide by, or multiply those and divide by 42. But this time we don't get the final answer. We're only going to get sine P. So when you cross multiply those numbers, sine of 80 times 25 and then divide by 42, you get a decimal number, and we're going to write that down correct to 4 decimal places. So it's 0.5862 correct to 4 decimal places. So this is the sine of this. This isn't the size of the angle. This is the sine of the angle, P. So to find angle P, we have to do inverse sine 0.5862. So I'm going to do second function sine on 0.5862, and I get an angle size, angle P, equals 35.9 degrees, and that's correct to 1 decimal place. Here's another example of a law of sines question, but this time I wrote it down sort of as a little mini word problem. So let's take a look at it. It gives you a triangle. It says in triangle ABC. So just draw a random triangle. Don't try not to make it look like it's a right angle triangle. These ones are always used to solve non-right triangles, and we'll just label it. Don't worry too much about scale or the size, and it says angle A is 70 degrees. So that's the first fact they give you. A is 70 degrees, and they give you the opposite side, 100 centimeters. So notice angle A and the side across from it is side A, 100 centimeters. So we have that relationship that I talked about earlier. Then it gives you side B, 90 centimeters. So here's angle B, opposite to it would be side B, 90 centimeters. Now we need to find all the missing sides and all the missing angles, so let's see if we can do that. Let's begin by noticing that we have angle A and side A, so I'm going to write that down. The sine of 70 degrees divided by its opposite side, 100. Remember, this is the relationship we're looking for right here. Equals, now I'm going to work with finding angle B because I have its opposite side, 90. Oops, 90 centimeters. So let's cross multiply those, recognizing that we're going to multiply these two and divide by 100, and that will give us the sine of angle B. So as we cross multiply, we do sine 70 times 90 divided by 100, and we get the sine of B to be equal to 0.8457. That's correct to 4 decimal places. And then we're going to find angle B by doing the inverse sine. So I do second function sine on 0.8457, and I get angle B to be 57.7 degrees. So that's our first fact that we found. Let's see if we can do some more, find the other missing sides and angles. So I'm going to say that angle C is going to be equal to 180 degrees minus the 70 degrees, which is angle A, and minus 57.7 degrees. So 180 minus 70 minus 57.7 gives you angle C to be 52.3 degrees. So we're going to write that on our diagram now, 52.3 degrees, 57.7 degrees. And the last thing that we need to find is side C, lowercase c here. So we'll start with that original relationship. Sine of 70 degrees, this one over its opposite side, 100, is going to equal to the sine of 52.3 divided by side C. So let's cross multiply those. 100 times sine 52.3 divided by sine 70. And that gives you side C to be equal to 84.2 centimeters. So that's the law of sines. The other law is called the law of cosines, and it's used when you're given 3 sides and asked to find a missing angle, or you're given 2 sides and the included angle. So I just have 2 more boards for us to look at here. Let's begin with this one right here. So here's the formula, and it says if you're given an angle and 2 sides beside the angle. So let's take a look at this one right here. Let's say that we know that this angle here is 80 degrees. So that's going to be given in the question. And we'll make this side we'll make this side 35 centimeters, and we'll make this side 25 centimeters. So notice the relationship. It's called side, angle, side. You've got a side, and then the angle, and then the side, and the angle is in between the two sides. And you're asked to find this one right here. So that's going to be the setup where you have to use the law of cosines. And it says that if you're going to find c, lowercase c, it's equal to a squared, side a squared, plus side b squared, minus 2 times a times b times the cosine of angle C. So look at the pattern of those numbers. Now type that in your calculator. You should be able to type it all in at once. 35 squared plus 25 squared minus 2 times 35 times 25 times the cosine of 80. Now remember, the number that you get there is equal to c squared, not to c, and it's 1546.1, we'll say. So take the square root of that number, and you get side c to be 39.3 centimeters. So look at the pattern of the numbers that you're given. You're asked to find the opposite side. Unlike the law of sines, you don't know an angle and its opposite side. Here's the other version of the law of cosines where it's rearranged, and this time you're always given 3 sides. So it's easy to recognize when you're going to use the law of cosines. You're either given 3 sides on an oblique triangle, or you're given a side angle side where you can circle them like this, side, angle, side, and you're asked to find the missing side. So with that information in mind, let's see if we can find cosine C. It says the cosine of angle C is equal to, and then you just want to use these two sides. Now it says a squared plus b squared, but it wouldn't matter if you did 15 squared plus 12 squared. The main thing is this has to be this number right here. The other numbers, it doesn't matter where they go. So we would have 15 squared plus 12 squared minus 10 squared. So the main thing is not where these two numbers are, but that this 10 squared goes at the end. That if you're finding the cosine of C, this angle, you have to be subtracting the opposite, the opposite side, divided by 2 times 15 times 12. So let's work that out, and remember that you're finding cosine C here, so this is going to be a decimal number. So if you do 15 squared plus 12 squared minus 10 squared and divide that by 2 times 15 times 12, you get a decimal number of 0.7472. So notice that when we're dealing with a trig ratio, you want 4 decimal places here to compare, so that we can say angle C is going to be equal to the inverse cosine, 0.7472. So if I do inverse cosine of 0.7472, I get angle C equaling 41.7 degrees. So I hope that helps you out. I'll assign some work for you on the law of cosines today.